Hello, everybody. Today, we are going to focus on what kind of operations can be done with functions. And before we actually do that, I'd like us to review some of the rules of exponents to ensure that we do these operations correctly. So we need to look at the three major rules of exponents. The first rule is known as the product rule. And we've been using this entire time that we've been simplifying radicals. But the product rule states that if you are multiplying two terms with the same base, so in this case, our base is A. If we are multiplying two terms with the same base, we can add their exponents. Okay? The second rule is the quotient rule. And the quotient rule states that if we are dividing two terms with the same base, we can subtract their exponents. And the third rule is the power rule. And the power rule states that if we have a monomial being raised to an exponent, you can multiply the exponents. So we're going to use these two rules when we complete the four main operations with functions. So we are going to look first at function notation before we start working with all the different operations. And the key thing is function notation is what we've seen on multiple occasions already. But this is function notation, f of x, the function of x. We've seen it as g of x. We've seen it as h of x. And we're going to continue seeing it this way because we're talking about operations with functions. So the first set of operations that we're going to look at is addition and subtraction. And the key thing is when you're doing addition and subtraction, you are combining like terms. Okay? So, how does it look? Well, it can be in two forms. It could be written as f plus g of x. And all that means is you're adding the function of f with the function of g of x. The same with subtraction. F minus g of x does not mean that we're subtracting f and g. What it means is that we're subtracting the two functions from each other. Okay? So let's look at our first example. Let's say it said if f of x is equal to 4x plus 7 and g of x is equal to the square root of x plus x, find f plus g. So all we know this means is that f plus g of x is equal to the two functions being added together. So f of x equals 4x plus 7. G of x equals the square root of x plus x. We're just substituting in these values. And now we're going to combine like terms. The only like terms are 4x and x. So it becomes 5x plus the square root of x plus 7. Okay? I would like you to do one on your own. If f of x is equal to 2x squared plus 8 and g of x is equal to x minus 3, find g minus f of x. All right, so we know that this is essentially saying g minus f of x equals g of x minus f of x. So that means x minus 3 minus 2x squared plus 8. Now remember, this minus sign is applied to both terms in the parentheses. So this becomes x minus 3 minus x squared minus 8. So our final answer in standard form will be negative 2x squared plus x minus 11. Okay? And that's really straightforward when adding and subtracting operations of functions. Okay? So let's talk about the next operation that we need to talk about, and that's multiplication. Okay? And multiplication can be written like this. F times g of x. And all that means is that you're multiplying the two functions together, f of x times g of x. So, for example, if f of x equals x squared minus 9 and g of x equals x plus 3, find f times g of x. So, what that means is that we are literally multiplying the two functions together. So we're going to do the substitution, x squared minus 9 times x plus 3. And in order to do this multiplication, we're going to have to use FOIL and the power rule. And get x to the third plus 3x squared minus 9x minus 27. And that is our final answer. I'd like you to do one on your own. If f of x is equal to 3x squared minus 11x minus 4, and g of x is equal to 3x plus 1, find f times g of x. Okay, so if we were to do this, we know that f times g of x is equal to 3x squared minus 11x minus 4 times 3x plus 1. Now in this case, we're not using FOIL, we're going to use distribution. And we're going to get 9x to the third plus 3x squared minus 33x squared minus 11x minus 12x minus 4. 9x to the third plus, not plus, minus 30x squared minus 23x minus 4 as our final answer. All right, so the fourth operation we're going to talk about is division of functions. And this looks like f divided by g of x. So f of x divided by g of x. Okay? Now the key about this, all right, is that we also have to identify where g of x cannot equal 0. Because that is a significant value. We cannot have the denominator equal to 0 because it's undefined at those x values. So let's go back to this example. If f of x equals x squared minus 9 and g of x equals x plus 3, find f over g of x. So this is a little bit different, okay? So step 1, okay, is you are going to state what the denominator cannot equal. So what I mean by that is we know that f divided by g of x is equal to f of x over g of x. So x squared minus 9 over x plus 3. So once again, the denominator cannot equal 0. So we're going to say x plus 3 cannot equal 0, which means x cannot equal negative 3. That's the first thing you're going to do. The next thing you're going to do is you're going to simplify if possible. Okay, so x squared minus 9 can be simplified because it's a difference of 2 squares into x minus 3 times x plus 3 all over x plus 3. Well, what we should see here is you absolutely can simplify by canceling out x plus 3. Okay, in the numerator and the denominator. And therefore, f over g of x is equal to x minus 3, where x cannot equal negative 3. Okay? I would like you to do the same thing for this example. And I'm going to write it here so you can have my example for reference. If f of x is equal to 3x squared minus 11x minus 4, and g of x is equal to 3x plus 1, find f of g of x. Go ahead and do that one now. Okay, so if we did this, we have f divided by g of x, which is 3x squared minus 11x minus 4, all over 3x plus 1. So the first thing we're going to do is say 3x plus 1 can't equal 0. So 3x can't equal negative 1. So x can't equal negative 1/3. Okay? The next thing we're going to do is simplify. So we're going to factor the numerator, and we're going to use the x in the box method and get 3x plus 1 times x minus 4 all over 3x plus 1. So now those cancel out, and you get x minus 4. All right, so f divided by g of x is equal to x minus 4, where x cannot equal negative 1/3. Excellent. So the last thing we're going to talk about today is the composition of functions. And the composition of functions is noted as FOG or GOF. This open circle is the symbol for compositions. Okay, it's the symbol for compositions. All right, so what is that? Well, we are forming a composite function. We are forming a composite function. Is a function within a function. Okay? So what that means is if you are asked to find the composition of f of g, you are literally plugging g of x into f of x. Whereas if you are being asked to find g composed of f, you are plugging in f of x into g of x. So what does that mean? Well, let's look at this example. Let's say if f of x is equal to x minus 5 and g of x is equal to x squared, find g composed of f of x. So I'm plugging in the entire f function. So I'm plugging in this entire function of x minus 5 into g of x. And where am I going to plug it in? Everywhere that there's an x. So g composed of f of x is equal to x minus 5 squared. So g composed of f of x is going to equal to x minus 5 times x minus 5, which leads us to x squared minus 5x minus 5x plus 25, which when we combine like terms is x squared minus 10x plus 25. Let's do another example together. Let's say if f of x is equal to x squared minus 3x plus 2, and g of x is equal to 2x plus 5, find f composed of g of x. So we are plugging in g of x into f of x, which means that we're plugging in 2x plus 5 everywhere that there's an x in f of x. So that's in two places in this example. So let's do it. So f composed of g of x is going to equal 2x plus 5 squared minus 3 times 2x plus 5 plus 2. Okay? So then we know we have the FOIL here, 2x plus 5 times 2x plus 5 minus 6x minus 15 when I do the distribution, 4x squared plus 10x plus 10x plus 25 minus 6x minus 15 plus 2. So now we're going to combine like terms. So I get 4x squared plus 14x plus 12. All right. And then we notice, oh, there's a GCF there. So I'm going to put it in simpler term and get this. And that is your final answer. Okay? One more example together before you do one on your own. Let's say if f of x equals x squared and g of x equals x minus 3, find f composed of g of negative 2. Now in this case, we've actually introduced a numerical value. So how are you going to solve this? Well, you're going to work backwards again. You're going to plug in negative 2 first into g of x, and whatever value we get, we are then going to plug into f. So the first thing we're going to do is g of negative 2. So that's negative 2 minus 3, and that's negative 5. Now we're going to take that value and plug it in to f to get our final answer. Negative 5 squared equals 25. So you will always work backwards. Now, I would like you to do two questions on your own. The first question, if f of x is equal to 2x and g of x, let's actually change that. If f of x is equal to 2x squared plus x minus 3, and g of x is equal to x minus 1, find f composed of g of x. The second example I would like you to do is if g of x is equal to 2x and h of x is equal to x squared plus 4, find h composed of g of negative 2. Okay, so for this one, we're plugging g into f of x. So this entire quantity of x minus 1 is going to be plugged into that x value and that x value. So fog equals 2 times x minus 1 squared plus x minus 1 minus 3. So we're going to have to FOIL out the x minus 1's. And we get 2 times x squared minus 1x plus 1. Then we're going to distribute. And you're going to get 2x squared minus 3x minus 2. All right. For the next one, we're going to plug in negative 2 into g first. So g of negative 2 is equal to 2 times negative 2. Then that equals negative 4. We're then going to plug that value into h. So h of negative 4 is equal to negative 4 squared plus 4. Negative 4 squared is 16. 16 plus 4 equals 20. And that would be your final answer. Have a great day, everyone.